fell in.
Yeah, so let's take a look. How would that look if we did do the, so we look at some of the plumbing sections here. That's perhaps a good thing. So we've done this section here. We've got the open floor here, and we had to keep that panel off, keep that panel off, these panels here. So, but I mean, one way to get around that is if you were to cut the OSB like on the edge and bond the OSB together, just so you can put up the walls. Now that does not address this wall here. So in that case, you would have to. I mean, one way we can design. Oh, we're going to design it for plumbing post walls. We just have to make an opening. It's only this, this opening like that, right? So if we designed it, so we shift the OSB around instead of just your regular grid pattern, we would make it such that, oh, well, you're just doing this 2-foot section that you need to access the plumbing, and that's it. So we could have designed it, and yeah, maybe we do that for next time, given that in this practical experience we had plumbing not in yet. So we can have two workflows. One is if you do the plumbing in sequence when you do the entire floor modules, or post. We want to have those options open. So let's look at the latest in terms of the CAD. Let's just take a look at what the future roof detail looks like. So here we have just to see what's a common here. Just so we understand where we go from the current state, just to always look at what's up front, so you know more like what kind of constraints you have in the whole build process. So now we've got the PV added. Okay, so that's what we're gonna look like. Let's see, do we have anything else here? Parts. No. Okay, so PV panels are started. So this is kind of the finished deal, and what we have now is more of the finished trim on top, including how you drain the water off the back. Now, since we're gonna have these long runners, and these are just 2x6s treated right on top of the finished layer of roofing. We're gonna mount the photovoltaics. It's kind of like, yeah, I mean, even though the slope is backwards, you still incline the photovoltaics pretty low angle, and low angle more like for wind loads. It's optimized more for summer. Like we put the angle on the Seagull Home 4 in Maysville pretty low, and that was largely for, we were considering wind loads a lot. Like we didn't want to incline it too much, because then you have a more difficult way to do it. Now we can set that angle whatever we want. Now in a fixed angle setup, this will be optimized for summer. Like for example, in the summer you might get like the best angle, because the sun is like what's the sun at, like 30 or 40 degrees, 30 or so, I think. So if you put it at 30 degrees or so, then you've got perfect, best utilization in the summer. We can even make a system where you can say lift it up in the winter to get a higher angle. Nobody does that. I mean, that's who's going to go through that work. We don't plan on it at this instance ourselves. So you've got 2 runners per PV mount. We have another extra one at the end here. You cap them. They're not connected to. They're not puncturing any through the membrane. They are attached at the ends, and they're attached. So let's uncover some of the detail there. So let's take off the PV panels. We take off the trim. So we're capping. So you see, remember what I was discussing about capping the roof membrane. So we're doing exactly that here, so you don't get UV degradation on the membrane, which is going up the side here. So if you unhide what's underneath, that looks like the membrane to me. Here I would also expect, I'm getting lost, let's just see view perspective. Okay, so if we look at the back here, there's more exposed here. That's just the, looks like my roof membrane. Well, that looks like the entire roof membrane right there. So we've got a bit of the trim on top, same on the front, trim that's stained brown, and then here what we have is another white piece of trim. So that's the final top OSB that we're going to put on later. So we haven't done this. Right now we're effectively at this stage here. That's kind of how it looks. We're stripping this back. Let's trace what we're going to do here. So that's the insulation, that's the decking. So right now we're at this, and we didn't put on these, the outside, the outer box yet. So we've got the trusses, the tapers, and that's the box we put on right now. We have the outer box to mount as well. The outer box, so let's, now this is a, yeah, it's not organized in a part tree. I didn't number this stuff here, but so we've got the structure. So
it's the outer box, huh?
Yep.
To go on up on top of the slope pieces, then the 3/4 inch OSB for the actual roof, and then the 2 layers of the foam board insulation, and then the plastic sheeting, and then the treated boards that are gonna hold it down. No?
Yep.
Okay.
Now so you do decking, so the roof decking.
Yeah.
But before the roof decking, we want to have the outer box, because that's what confines the entire deck.
Yeah.
So we need to get into that part, which we discussed. That's a 2x12 and a 2x4, and we discussed that we can potentially staple that together just on the whole edge at 3 or 6 inch schedule, so that it's tight. 6 inch schedule means that the actual holding force of one board to the other, based on 25 pound holding strength per leg, 25 times 40 fasteners, you got 1,000 pound holding force just with the staples. That's your back of the envelope calculation. So yeah, that'll work, that'll be fine, unless it turns out that we're not able to staple the 1 inch staples effectively into this assembly for some reason, like it's just too messy, like the edges aren't clear and whatever. But I think if we use 1 inch staples, we should be able to do that. And the only trouble would be like maybe make sure that they're together. If they're warped up, you're hardly going to catch them. So press them down and attach them together. So you might, when we prepare these boards on the ground, so we'd want to do like make this one assembly, the second one,
and they're going together like this?
Up. Yes.
Okay.
Yes.
And the staples are going like this?
Yep.
Okay.
Yep, exactly. So we do that on the ground. There's no way we can carry it up there that doesn't have the other side attached to it. So how does the rain drainage look like? So we've got a gutter below that. How exactly are we capping this? That's trim. There's some complications there, but how this all works, because what you need, there's a constraint where you have to have a gap for water, and you also have to hold the gravel in. So last time we used fiberglass screen to hold the gravel, and just a little layer, like we've got like 1 or 2 inches of gravel. But you got to hold it in so it doesn't wash off with the rain and stuff like that. So there's details there. I won't get into that. That's a
And does anything hold the plastic down on that side, or just the treated 2x6s on top?
Oh well, we're gonna have to on the side here. We would have to run the plastic down into this and have some kind of probably use a termination bar. We typically use a termination bar to hold membranes against. So we're gonna have to drain down, right? Because you're draining.
Yeah.
So you have to go like this and down. Therefore, you're using a termination bar. What's a termination bar? Like EPDM roof. Could use the same thing as they use for EPDM. Something like that. It's this thing, just a long piece of metal. It's aluminum,
Okay. Yeah,
and you screw it down. Yeah, yeah.
Okay.
Just a thing that you screw down the edge.
So does that penetrate the membrane, or does
it does, and that's why you have to use this heavy caulk, this or roof mastic there. So, and that stuff is super sticky. That stuff works. So you got nails. Like if these are joist hangers. So the rafters or the PV mounts, they're connected only on the ends, and they're connected with joist hangers. So that's what we got here. Those are joist hangers. So you got a very stiff connection. See, it's protruding out. So you're attaching that trim with a gap for water passing through this.
Yeah.
On the front, no, it's the box is close to the right next to the membrane. You're enclosing it on the three sides, leaving the fourth side open for drainage. That's the thing. Okay, so what do we learn? Let's talk about what we learned from yesterday. So we go back to the videotape. Barry, do you have any decent video or not particularly?
Time lapse, is that what you want?
Yeah, but I'm gonna go into pictures. So just to kind of review. Okay. In the pictures, so the problem here we had. Which one?
Under temp.
Which one do I want to do?
Well, there's time lapse. Those are the last clips that I got. Let's put it at the root.
Which one is the best one? Which one do we want to take a look at?
Last. That's second.
Let's see how that looked. So we've got, just to review that. Trusses going up one by one. Then we'll probably see the edge board of the trusses.
Oh, did you interview a lane there?
Yep, so we got the edge board, fixing those together. And that's the one section. And then what next? Then we get into the wrong way, put it back down, other way, and then we just drag it up that way. Bam.
That part
That's
sounded
pretty
like
cool.
we should have a crane. It's a little too high for the skid steer, and
Yeah, so let's take a look at what possible solutions are here. The issue was that we're missing like a foot, right? Forks are just not tall enough.
I
So-
thought of an idea.
Okay, go ahead.
That, let's put the heavy end towards the back of the forks, and then lift up the lighter end over. Because your forks, your skid steer will hold that heavier end, right? What you're trying to push up. So if you put your skid steer behind that and maybe put a board so your forks could hold on to something, and then it'll get high enough for the lighter end, and then I don't know.
You want to do we can do for example, just like we have the fork extenders, we can put on a 20-foot, like 5 feet more, so we have, instead of 10, we've got 15 feet, at which point we can lift the whole thing lengthwise, and then we can insert it up there. That's one way to do it.
The lighter end is easy. It was just that heavy back end that was just like.
We can do that. So is that what we want to do? I like it.
I like this an idea.
I like that idea, because we let the forks do the work. You can get like quite far up there in terms of just like that 1 foot. If there's people, but then again, do we operate on the scaffolding? Right, we don't want to get on the roof. The roof, you guys did the scaffolding, not the roof. That's good. if you're on the roof, that's more dangerous. So scaffolding is a good idea, and then we just have to catch that upper edge. But I think we can do that. I mean, basically, like on the scaffolding, we can even have a rope and then like pull it down if it's too high, because that angle is going to be going up when we are throwing it up there. Yeah, we can do a very simple fork extender, which is simply a 2x8 top and bottom. So just like those forks are made of steel, we could do like a small, 10-foot thing that we stick onto the forks that extend it even further. Because it's not the question of weight; it's just the question of bad geometry that you can't hold it. So yeah, we could do that. But if you're gonna do that, then you need to put a crossboard underneath. That's the only thing. Now I think that's okay, because I mean that crossboard would have to remain underneath. At which point, you drop it down on the joists. You have to pry it up and unscrew it at that point.
Well,
So that's the thing.
If you wanted to put the board on top of it rather than underneath.
But you got to catch it with the forks. So if you catch it up on top, that's worse. When we put it up there and we got it in place and the board is underneath it, if it's just offset, you can take it right off.
I mean, unless you put it on top, you have the faceboard here and you have that board on top here, and then the forks can come under the faceboard and grab that. And
We can grab that. The angle will be worse for you guys. I mean, if that means let's see. No, the angle actually will improve, wouldn't it? I think it'll actually. Yeah, we could do that. Yeah, we could put it on top. Therefore, we don't have to work from the bottom. If you take a look at, let's just draw a quick reality check here. So I'll just draw some lines to reflect the realistic geometry. So we've got so we got the forks. We're going to get them like this up. We're going to be angled up there with the forks. We're going to have the big platform hanging up there. There's some kind of an angle, but we're saying we're going to do this because we're going to catch the wood member that's going to be on the top. So we're going to have this board, that's here.
So that board is going to have to hold 500 pounds. It's got to be screwed.
Is that thing 500 pounds? I ain't 500 pounds.
If it's more along
It's,
the lighter edge,
It's more like, I would say it's more like 300, 200, 300 about. I mean,
Yeah,
what do you got? You got a
every
2x12
side
that's 10 foot long, right? And it's slit into almost half. It's like, so you effectively have like 4 2x10s by 20s plus the front and back, let's say 5. Okay, just look at weight of 2x12, 20 foot long. I'd say that's like, what, 75?
That's a big range.
It's not. That's not going to be more than 80. It's
Well,
not
I,
300.
I've moved.
oh, look, it says 100.
I've moved that kind of stuff by myself. I didn't lift the whole thing, but I can comfortably lift one end at a time because I've got a whole stack I moved here a while back.
Okay, so
yeah, it probably around 100 pounds or more, I'm gonna guess.
okay, so let's say 100 pounds. So we got 400, 500. You're right, actually, it's quite a bit. So yeah, yes, we do exactly that. So that thing is attached to 7 members. So 7 divide 500 into 7, you've got 50 or 100 pounds, no more. So that means even a single screw in each, because each screw has 100 pounds, is rated for 100 pounds of holding force. If you've got 7 of those members, you've got 700 pounds of holding force. So yeah, you can attach that easily on the top. You can use the forks to make it go in there. Let's see. Do transparent. So there's your. It looks like that. That's fine. You can hold it all up.
Yeah.
I like it. So we just make these extenders. I can do that. Just knock together. You can take a 2x4, 2x12, or 2x8 on top. Easy. Let's do it. And then we just have to the end of the forks. We only need to go. Right now we're at 10 feet, so we only need to extend, by a few feet, like
Yeah.
3, 4, 5.
Do we need the extenders if you're going to put the 2x12 like at 2/3? We already
It's not
Yeah.
two thirds. It's 20 foot long. The forks are 10, so we're exactly at
you're
half.
going the long
Yeah.
side.
So we gotta do a little bit now. The way to address it is, okay, forget about the extenders. We're gonna do exactly this, and we're gonna attach a belt or a rope to the forks, and then we have to let it release it at the end. That's another way to do it. I think that's actually even easier, because if you hold the top, preventing from falling down. But it's, you know, the forks are only so tall here, right? So you gotta do.
Marcin, can I touch them
Yes,
up real
ma'am.
quick? Guys, if you can't see the designs he's talking about how to lift the module section.
How to do this
Yeah. Oh, yeah.
without getting hurt or without breaking it, or the problem is the forks don't reach to the roof. That's the issue we have.
So yeah, we
So
put that cross piece in
yeah,
there.
cross piece
If it's
and
at
a rope.
about 9 or 10 feet,
So
and
here's
then
gonna
you've got
tie
the
down
heavy
the back.
side.
oh yeah, so okay, yeah, you got the heavy side. Oh yeah, by the way, if it's on the heavy side, you might
On
not
the
even
heavy
need a rope.
side, Yeah.
Okay,
And that's what I think we could even cheat it back to probably 8 or 9. Because
So you got a
you've got
rope.
the heavy side, and then we pull it up there, and then we could probably even tip it on
yeah, sure,
that middle one,
sure. Tip it and it's
pull,
back
and
down.
then pull
That's
it
good.
on up there.
So what you'll do is, once we're up on the roof there, so that's our building. You know, our building is here. We're doing that.
Yeah.
Pull it down from like this. You gotta just pull it down at a certain point,
Yeah.
wherever that building is.
The issue we had
And
with
that-
that was that because the heavy side is outside and
Mhm.
if your lever isn't great, like Brad and I were literally hanging off the thing, and it wouldn't even budge because the lever was just so bad. So you need to be a certain way because all the heavy stuff is on the outside.
You need to be, I would say, you need to be like a quarter to 2/3 from the, like what I have here, pretty
Yeah.
much, where it's.
That would do
We
it.
get it to this. I think we can do this.
Okay.
I think that's doable right there. So we've got like a foot. You know, the problem is that 1 foot height that we can get. We can get quite a bit. In the extreme case, say you do. We're not far enough to the right in this picture. What if you had to make the angle actually like much greater? Like, oh, we gotta do this. not that bad. I mean, you could do that, but like you got that. Just put a piece of rope on there so we can grab it down. But that means that the building would be like really close. You know, the building would be like right there. Like we could do this. Now the building is going to be shorter by comparison here. It's going to be that. So you got a rope on that, so you pull it down. I think that's quite doable. Well, we'll see in practice, but something to this effect. We can definitely get the weight bearing on the forks. So we got the heavy side on the forks, and then it's a question of pulling it down and pulling it off.
Yeah, the biggest safety benefit is just knowing that those forks are going to prevent it from sliding back, and that's what
Yeah.
we're really running into.
Mhm.
Is that scary
Mhm.
moment.
Yeah, I think that's quite doable. I would feel comfortable while doing that.
Let's try that.
Sounds good.
Okay.
Okay.
But first trusses.
First trusses, indeed. So,
So priorities this morning is to finish this first rough section and the plumbing and the floor of the third floor section, right?
priorities are to get the box that we put up there, put it into place. I would say put the box around it, because we can't put the second section without the box around it.
Yeah.
So now
that's
we
what I
put,
mean. Yeah.
yeah. So, in the build order, this is the ordered. So, once again, okay, so let's look at without the top plate. So we got this. Let's do view orthogonal. Okay, so let's hide all of that and we'll go through that process again. Trusses. Yes, we got it.
Guys, this is the free CAD you're going to be learning.
Oh yeah, it's so beautiful because you learn it in 1 hour, but you have to use FreeCAD 16.
Yep.
Because I can't teach you FreeCAD 1.0, which is 2025 release. It just got released this year. It's much more complicated. But you can do everything and more than you ever thought you need in FreeCAD 16. And
James is working on it.
that's great. And I don't know if we have access to some donated laptops. We should have a bunch of donated laptops. We put old Linux on it and we run this and everyone has one available to look at. Because it's kind of a painful to make it, to work with FreeCAD 16 on a modern computer. It's not great. It's not easy to do.
I see.
Because you got to install an older operating system which still runs FreeCAD 16. Okay, we'll take care of that. But I think we can probably get donated laptops. We've done that before many times. So, and get like a whole bunch of them, like, for every person. So, okay, the rim, we did that.
Mm-hmm.
If we go to the pictures.
And the 2x6s, I think, for 2x4s.
So the rim looked like so on here, that's the rim. And these, are we still here on that's the first section, right? So the rim is starting right there. We still have a 4-foot section of rim that we need to get there, but that's what the rim was. It was 3/4 OSB.
I think we did that.
Yeah, we did
Yeah,
that.
you
We
did
got
finish.
the-
So that was
yeah,
that right
we
there.
got the OSB and the 2x6s on that side.
Yep.
On both sides.
So,
Okay, yeah.
yep, you got the 2x6 rim. You got that on the front and back. What is that for? It's to connect on the front, the veranda, and any structural additions on the back. 3 is the, oh wait, we got 3. We got the taper box, which is, this is where we're at right now. Now we got to shift it into place. And what does in place mean? It means 1.5 inches on each side, everywhere. Okay, that's 1.5 inches there,
Also, that
all
thing
sides.
is very flexible, and we didn't square it. We should probably re-square it up there.
If you, yes. And how do you do that? When you start putting it into place, if you put that into all the right corners, it should work, and we'll see how good we are. We definitely try to keep this side straight. This side was quite straight, so maybe start by aligning these two, and then fit that to place. You should be able to do it. The walls, according to the string line on the back at least, it's pretty straight here. On the front we didn't run a string line. We don't know what it looks like, but I can guarantee that the back is quite straight, so you should be able to get 1, 2, and 3 of these points. And if the distance between, if you guys did 20 feet between the actual outer diameter, outer distance to the walls, we do have pretty much exactly 20 because you guys did that. So yeah, that means the fourth corner should be pretty close.
Would
We
you
do.
remind my crew, like when you say run a string line to find the square,
Mm-hmm.
you're talking about, you guys remember what James
The
showed you
stakes.
guys? Where would you run the string line in order to find the square?
Well, you're not doing square. We don't have the last corner in here. Unfortunately, we don't have a full house yet, so we
Right.
can't run the string line to the 4 corners. But you can run it as far.
Itself,
Yeah.
Of itself, you can
Yeah.
run it like diagonally. Okay.
Well, but like, yeah, that's the thing for squaring things up. We did that on a foundation. Here, I mean, we don't have the 4 points to do that yet. We can do the 4 points on the first module itself, but not really right now because there's irregular shapes up there right now. So, but we can. I think I showed some of the pictures of the string line. Where? No, I don't have it. Don't see it. But string line, let's see, is there one back there? No. We ran a string line, so right now, while on the,
Okay, this is it. This is the structure.
so the tapers, that's what we have right now. This is a picture from the roof. String lines, use them whenever possible. Right now here, we ran string lines before, so we got this decent, and it should line up to, my guess would be, will be like within a 1/4 inch. That none of the sides are sticking out more than a 1/4 inch. And yesterday we talked about that the allowed tolerance off vertical is actually ½ inch off 8 foot vertical. So it's tilting a ½ inch. It's still code actually. So that's what we said yesterday. From looked that up. Back to the CAD. We're here, and that's, you just saw the picture of that. Wide side on the front. It drains to the back. We've got a drainage mechanism. Oh, I hid my things. View. Panel.
Oh, it drains to the back?
It does.
To the north side?
It does.
Yeah.
Oh, I see. Okay. So,
Why?
will we have to, so will we have to lift and put something else up there for solar?
We
Yeah,
showed
the
it.
solar's going to be tilted.
It's going to be on top. Oh, yeah, you can incline the panels whatever you want, even though it's pointing back. It's a slight angle backwards, but I mean, that means you can still, doesn't prevent you from inclining the panels whichever angle you like. So we're still good on that.
Okay.
It means that the supports on the back are just, this much longer, but that's fine. So, view, panel, panel tree view. Oh no, that's not the one I want. Call this the tree view. Let's get rid of this one. This is the tree view, part tree, right? Okay, so we're going to this as our next step. I'm going to make it solid. Save that. Okay, so this is what after we get the box, the tape box all squared up, move on to this box because that's a dependency for the step of now the roof deck. So the roof deck, because it goes up to, it's bounded by that box. Okay, so you got the roof deck, and then after that insulation. We can leave that at here and move on to, from here we can go into the next section because we're covered from the elements largely. I think it's more worthwhile to do this side now. So yeah, we would move on to the next section. So is that pretty clear?
You have a printout on that shows the dimensions and stuff, or do we
The dimensions of what?
dimensions of that outer box?
The dimension of the outer box is 12 by 20.
Right. Yeah, I know the overall dimensions. Yeah.
Well, so this one, what do you do here? And make it a 12 thing, 12 foot long. You're
Okay.
talking about the rim board?
Yeah. So it's
It's
going
12
to be
feet.
the 2 by 12 and the 2 by 4,
Yep.
basically. Yeah.
Yeah, exactly
Right
12.
on top. Okay.
And the way we have it here,
That's all.
yeah. The
Okay.
side one is exactly 20 minus the 1.5 here, right?
Okay. So that's really all there is. Okay.
That's all there is.
Okay.
Mhm.
That's easy.
But you have to remember that the front is 12, it goes all the way across, and then the side one is 1.5 inches shorter.
Marcin, what does crew look like on this? Like, how many people are up on ladders? Like, where is our, like, how do you want to station people?
So what's the workflow here? You build so 4 people on the scaffolding on each corner, and then you move this taper box, arrange it into position, just line it up.
Okay, and 4 people can do that?
Yeah.
Okay.
You take a pry bar or even by hand. A single person can lift a corner by themselves because that's only a quarter of the weight. So you can lift it up. You can use a hammer to bang it, don't break it. You can do pry bars. So pry bars give you mechanical advantage. So if you're very easily, you can just think about all the kind of different tools you've got. Pry bars are good. Hammers. Lifting it up. It's not too heavy, like especially the light side. I mean, those you can.
Yeah, but don't forget
Sorry.
the heavy side has 3/4 or whatever of the weight, and
Yep.
lifting 100 pounds like this is awkward.
Yeah, you can't do it. Use a pry bar. Use a pry bar and then kind of slide it and it moves it a 1/4 inch. Do it again until you get it right into place. So there's a little bit of technique of how you do that, but get the pry bars with the flat edges and start moving it around. Just like, for example, like that cabinet right there is actually quite heavy. It's like a couple of hundred pounds, few hundred pounds. One method where you move things, like say you've got a 1,000-pound block of steel on the ground. As long as you can get a pry bar underneath it, you can move it with a single person. Like I've done that, like take like a 1,000-pound thing. What you need to do is, if you have a long pry bar and you get an inch underneath the heavy object, this is calculations 101, it's a 4-foot, 6-foot pry bar, let's say, and then you inserted it 1 inch underneath. What's the mechanical advantage you're getting when you insert 1 foot, 1 inch out of a, say, 60-inch pry bar? 60 advantage. So if I'm going to lift, so say I get it under, you know, bang it with a hammer, then I lift it so it actually slides off. If I'm lifting it, how much can I lift? If I'm a sissy, I can lift 50 pounds. So I'm a sissy, I can do 50 pounds, but I multiplied it 60 times. So a sissy can move that 3,000-pound block, if that block weighed 3,000 pounds, just by the pry bar catching the ground, and at a high enough angle, it basically slides. So that's mechanical advantage at work. Like Archimedes said, give me a lever long enough, I'll move the world kind of thing. That's completely true. There's the great power of gear downs, which from tiny motors, you can move thousands of pounds if you have enough gear downs. So that's an example of a pry bar where you can move that, you know, super heavy objects that you never think of building. And for me here, I had to think about that a lot, or just do that a lot, because a lot of times nobody was here, right? So I just had to move some heavy object, and I had to figure out, well, how do you do that? So you got pry bars, you got extremely powerful tool like the pallet jack. I mean, you can move a couple of 1,000 pounds on the concrete floor yourself. I mean, it's awesome. Then you've got the hydraulic lift table that you've seen. That thing lifts like 1,000 pounds. So for example, when you mount a heat pump and you are a single person, the heat pump weighs a couple of hundred to whatever, how many hundreds of pounds. You got to lift it precisely to a wall. Yeah, you just, you know, press it, pump it up, precisely into shape, no problem for one person to do it. So you always have to think about, like, especially if, as you get older, or if you don't have the strength, you always think about, well, what are the different ways I can make up for that? And there's plenty of ways. Just, it's like, there's incredible things you can do if you just know how to do them. And it's an application of using pry bars and things like that to make it work.
I think safety-wise, while we're up there and the trusses on the second module too, maybe nobody should be on the ground in the building or around, because yesterday we dropped something and it broke a metal fitting on a nail gun. It's definitely going to break your foot. Like,
so
if you drop a hammer by accident or a pry bar.
I would like to suggest that people wear this. We now have structures above us. It was not the case before. Right now we've got the joists, so hard hats are required from today. Keep those on if you don't want to bust your head. I had my head all the time, but that's because I know I have a hard hat, so I don't pay attention. I mean, that's what happens. Like getting into the skid steer, man, that thing hit your head all the time. I don't know about you. I hit my head all the time when I get into the skid steer.
Oh no, I haven't done that yet, fortunately.
Yeah, because probably you know that you don't have a hard hat. I'm like, I just want to get in there, and I know that I'm protected.
Some of us are taller than others too, Marcin.
Yeah, but wear a hard hat is the bottom line.
You guys all got that? My crew? Okay.
And hard hats are hanging on a wall, so grab them.
What do we want? While we have your 4 plus doing that, like there's enough for another crew?
Oh, there's plenty of stuff. For example, we can do, if there's 4 people working on that, let's talk about work breakdown once again. 3 crews, put these together. Use a staple gun, the 1-inch staples, 1 inch by 1.5 inch staples. Take a 2x12 and a 2x4, put them together. That's the roof box. And make them, and find the right section. We do have 20 footers, so you can take a single 20 footer and just cut off 1 inch. If you want to do that, those get heavy. So you can do that. That means like 2 or 4 people. 4 people. We just put it into place there on scaffolding from the side.
Do you have a blueprint for that? Because I think they missed when we talked about those.
Yeah, it would be good for them to learn to do it off of the schematic. If you want, we can run up there and grab if you hit print on there, if you're able to print that, then we can send someone up to grab that. But,
I'll draw you on a piece of paper. This is, take a 16 footer or a 12 footer. We have a lot of the
You need 20.
16s. You need 20. You need 1.5 inches less than 20. So let's put it on a piece of paper. So if you want to have 3 teams do that, get those ready as we get that box in place. That's a bottleneck right now. We want to do that. Now, you can, if that's a bottleneck, if you have enough people, then next trusses on the next section are doable right now as well. If you want to get into that. So where we here like this, beyond where we finished, I mean that whole section is ready for trusses as well. Now, so there's four people on each corner. We have 6. I believe we have a total of 6 scaffolding. So let's get out the rest of the scaffolding. There's 2 more in the old workshop, so let's use them all because we need them. And get out more of the ladders. We've got more ladders behind. I can grab some of those. We've got those ladders lying around. We only have like 3 or so tall ones here. We can in fact take that one and use that one too, because I mean it's not being used right now. So that one, that's right there.
all right. And are there any guts going in today for?
I'd like to do the plumbing so that we can tomorrow we can close off section 2 and perhaps get all the walls for section 3. Okay.
But you want to do some of the plumbing later today?
I do. I want to do it like lunchtime, so it's like not bottlenecking.
Okay. Because
Yeah.
I did want these guys to see some of that today, and they have a little bit of time after lunch. So.
Now, what's happening? What I would just suggest is like you're just gonna be watching me measuring stuff for an hour and stuff, and then I'll leave it all exposed. But the steps there are you measure the right lengths, you cut the fittings together. We have this. Suzanne, have you seen this one? This is what I drew up in my ample spare time 2 days ago, and that's what it looks like. It's exactly that. It's coming from the kitchen sink to it's not to scale, but it's the kitchen sink. Tub outlet here goes right. This is the drain here going to the out of the house. Bath sink, tub 2, toilet 1, laundry and bath sink 2. So, and we're plumbing in this side and just stubbing out this side, meaning that we're gonna put those. Well, we're gonna put these things in, but cap them. On this side, we can actually put these top tubes and do penetrations within the OSB itself, so that you have it ready for attachment, like right there. We don't have to go cut a hole.
He's supposed to be here, don't worry.
Open the door, Allison, and let him out. Oh, let him out.
Oh, it's on the trap?
Yeah. So Suzanne, this is so beautiful. That's the entire plumbing system of your house. Can you believe
And I
that?
was gonna say, like, depending on, like, I could see that how to extend that out later if I wanted.
Oh, you
to
can
add.
extend it. If you want to extend it, down here we're going to be going into a pump vault, so you can
Yeah.
add additional buildings or other rooms or facilities that go into that same pump vault that go into the biodigester. Now here, if you want to expand here, you
That's where
take this one off and just run it straight.
Yeah.
I mean, in fact, if you want us to,
Same for all of those, yeah.
um,
I mean,
you can. The most sensible, you said you might want to turn this into bathrooms, so
Yeah.
so do you want me to put instead of an elbow, put a T in there? Because I can put a T that you're ready to just go out, continue the back.
Yeah.
Yeah,
Yes.
yeah, you want to do that?
Yeah.
Sure, we could do that. We've got the parts. So instead of the laundry,
I do.
yeah,
Just put a T everywhere, yeah.
you want me to put like a T? I mean, it doesn't make sense. Look, a T doesn't make sense here, right? It could make like you're not going to build more bathrooms into your common space, right? But do you want me to put T's into this space? Because that's where the
Yes.
next bedroom would be.
It's not going to be a bedroom though.
Okay, so you're
This is
gonna
more showers.
more facility. So
I mean,
so here you want me
Yeah.
to do T's off of these, okay?
yeah.
Friendliness is next to godliness.
Now, I don't have a part for this 3-inch T here because that's a closet bend. It's a 4 to 3-inch fitting.
That's fine.
Okay.
We will make that work.
Yeah, you'll make it work by, I mean, what you'll have to do is cut it off, add this fitting, and extend another pipe to it. Or if you want me to, which is simpler, I can just stub out a pipe here and don't do the closet bend here, assuming that you're gonna put it in later. So I can do a cap a 3-inch pipe here that we're not going up into the floor because you said you don't know where your toilets are gonna go, so just
Everywhere.
stub it.
Toilets.
Okay, so I'll just stub that
In
one.
every room, yeah.
Okay,
I think the
No,
same
multiple
way.
toilets in every room, sorry.
You guys are eating too much fiber.
okay, so stub this. Don't put the closet bend.
We're gonna put in those double toilets like on the Saturday Night Live episode, so
Yeah.
people can sit next to each other.
For the couples,
Yeah,
yeah, I
the
remember
couples
that
toilet.
sketch,
Or
yeah.
maybe you should get the hidden toilet from that other SNL sketch.
The invisible toilet.
So I'll put. So this one doesn't get it. Gonna stub it here. So basically, you want.
Closet bend.
It's called a closet bend. It's a water closet. Closet bend is the name for the thing that goes under your toilet and then at an angle. Typically, those things are 4-inch toilet inlet, and then 3 inches to the other side. And okay, so you want stubs. You basically want T's there. And
Yeah,
these
that would be
3.
fine.
Okay, so do a T there. And T there. But these ones we're going to do like that because that's ready for one bathroom. One full bathroom
And
there.
we might, like I said, where that second toilet is, that may end up being laundry. We may put it in at the end. We don't know yet.
Okay, so here, yeah, okay. Mm-hmm. Yeah, I'll stub a T in there, T, T, T.
Yep.
And then just a stub there where you can extend 50 toilets to it. There you go.
all the toilets in Caldwell County.
Now on a 4-inch, so what's the code limit where it's actually practical? Like, what's the maximum number of toilets you can put on a 4-inch pipe? So we can Google
There's
that.
no code in Caldwell for that.
Well, but you also want practicality. Like, is it
Oh,
going to get
oh,
clogged
oh.
up? So let's look at what they
Depends on
recommend.
what you're putting in for our biodigester, right? How many totes?
No,
just
because
the-
that's scalable. That pumps like
Yeah.
50 gallons a minute or whatever. So you're not blocked
Oh,
at the
you're just talking
biodigester
about,
side.
like,
Just
You're
the
talking
pipe
about with a
itself.
the
fo-
drainage itself.
Yeah,
Just
if
the
we stub
3-inch
that
pipe,
out,
you know.
max number of that one there is 3-inch. Max number of toilets allowed by code
Like when you're talking
on
about, you're talking about like
3-inch
international.
drain.
Talking about international.
What's the
code.
answer? Is it 4?
No, it's just volume. Just,
Oh no, you can do 14 toilets. There you
there
go.
you go.
Oh, that's
Great.
They need 50.
Yeah, there's more than 14 people in Caldwell County. We all need to be able to go at the same time.
IPC International Plumbing Code. A 3-inch pipe could support up to 14 toilets. There you go.
There you go.
Who's per minute?
Wait, what does it say? Oh.
Fixture units. They call it
Oh, okay.
fixture units, and a toilet is called 3 fixture units. Yeah. So there you go. You're set for expansion.
Excellent.
Okay. Let's do it. So workflow: square up the box, make the top roof box, and then put on the OSB there. What other tasks do we have at present? We can do the only thing that's clear that's doable right now is you can put more trusses on. So if you have 6 scaffolding, there's 4 people on scaffolding working on one section, 2 people on scaffolding can work on trusses, getting more of them in.
Okay.
That's what we can do right now.
So do we need people to bring over scaffolding?
Yes, we do. They're in the old workshop, so
Okay.
we can do that.
Okay.
All right. So crew,
Marcin, I have like a peripheral question. Are we still planning to tour your house? I'm really interested
Oh, yeah.
to see a greenhouse if,
Oh, yeah.
if it's up. Yeah.
Yeah, we want to tour it whenever's a convenient day. When do we want to do that? You want to go tonight?
After work.
So after work. Are we talking after the 6 p.m. lecture or instead of the 6 p.m. lecture? Let's go. Try to keep it 6 to 7 and then 7 to 8 for the
Okay.
tour. Yeah.
Is the sun still going to be up? Great.
Sun's gonna be up to like 8:30 or something.
Cool. Good.
Okay. So Mom, warn Katerina about it tonight.
Yeah, that's what she said.
Yeah.
I wanted to do the same thing.
Już zobaczyli ten dom u nas. Mejzu.
Między 7 a 8.
Aha. Zapytaj się, czy można... No tutaj co? 10 ludzi. Mhm. Przestraszę się, ale zobaczymy, czy możemy to zrobić. A jak, nie, jak powie, że nie, no to ludzie trzeba robić, co ludzie chcą, więc chcieli dzisiaj, więc... A jak nie, no to jutro. Dobra.
So you have the disc in there if I can get
Yes, sir.
recording?
I need to get my
It was.
internet fixed so that my